Okay, welcome to the part 2. Okay, here we are going to see the first scenario, selecting or electing a root switch. So we say how root switch is elected. Root switch is important as a central point for STP topology. Once the root switch is selected, here is selected, okay, uh, that root switch then becomes the central switch, and ideally it should be better in the configuration compared to the other ones, because it's going to do a lot of stuff for the other switches. Okay, and this becomes a central point. So this switch is going to talk to this switch is going to talk to this switch, it kind of becomes an hierarchy. So let's see how does the STP select the root switch. In scenario of multiple switches like we have, the first and the foremost step is to elect the root switch as part of the best practices. The root switch should be central switch, and ideally it should be better in configuration to other non-root switches. Now this, if we consider this, we'll see in a minute how this is coming up to a root switch, but if this is the other non-root switches, then it needs to be little better configuration, ideally, not mandatory, but ideally. The election process is done on basis of its bridge ID. Okay, so the election process is done on the basis of bridge ID. Okay, we say bridge ID. Okay, the bridge ID comprises of two important part. One, 16-bit bridge priority. Okay, 16-bit bridge priority. Okay, and second, 48-bit MAC address. 48-bit MAC address. All right. The default priority of any switch is 32768, right? That's the default priority of any switch. Now if there is a tie in priority, the lowest MAC address is used as a tiebreaker. Hence the bridge ID comprises of two parts, the bridge priority and the MAC address. Okay, now let's see how we start the election process. Okay, let me clean up this a little bit. So that we have some more space to write down and draw some numbers. All right, great. Select the brush. Okay, now we all know the switch shares BPDUs every 2 seconds with each other to perform the election process, and the lowest bridge ID wins the root bridge election. So once they all get connected, once they see that there is a loop, they share the BPDUs every 2 seconds, and based on that, the one that is with the lowest bridge ID wins the root bridge election. The bridge ID comprises of two key components, the bridge priority and MAC address, which we already seen. So the situation is something like this: switch C, or rather, sorry, switch B, switch C, and switch E, right? So you can see here switch B, it has got the MAC address as 2222 and bridge ID as 32768. Switch C has got the similar bridge priority. Okay, I said ID, but it's a bridge priority. Okay, and similarly for switch E, it has got the same bridge priority. Okay, they all have default 32768, 32768, and 32768. Okay, switch A and switch D, they have similar, okay, 500. Now for switch C, okay, switch B, and for switch A, they all have 3, 2, 7, 6, 8 as the bridge priority, and switch A and switch D, they both have 500. Okay, switch A and switch D are tied with a lower priority of 500. Now they are similar. Okay, at least in this case A and D are much better than becoming the root switch compared to CBE in, but because all three of them have 32768, which is higher than 500. So the lower the bridge priority, the lower, the better it is to be getting elected as an root switch. Switch A has the lowest MAC address. If you see, it is 1111, it is all 11 here in switch A, and switch D it is all 333, right? And hence it will be elected as a root switch or a root bridge. Okay, so compared to all the 5 switches here, okay, there is a tie between switch A and switch D based on the bridge priority, which is 500 listed here, again which is 500 listed here. Now there is a tie, hence based on the MAC address, this switch A is going to be elected as a root switch. Right? This is going to be elected, right? Now always be very careful before adding any new switch to the existing topology. If its bridge ID is lower than the existing root switch, then it will overtake as the root bridge. So we have to be very sure about when you add another switch here. Say for example, you have another switch here. Okay, if you add one more switch here, then if this is got a lower priority, then this become the root bridge, right? So that's what you have to make sure. Okay, all right, now we have seen the first step, which is how to identify a root switch. Okay, root switch. The second step is to identifying root ports. Okay, the root ports are identified on the basis of lowest root path cost to get to the root switch. Okay, if switch B has got a path from here to here, it will actually see what is the cost. Okay, so the cost for 1 Gbps is 4. Okay, we will see a whole list of it. Okay, starting from 100 megabits per second and 1 Gbps, which are listed as 4. Okay, then 155 Mbps or 10 Gbps, which is 2. Okay, so the root ports are identified on the basis of the lowest root path cost to get to the root switch. So what is the cost of switch C reaching to switch A, similarly switch B reaching to switch A, similarly from switch D to switch B and switch A, what is the cost involved, and from switch E to C and finally to A, because everybody needs to go towards it, right? Why? Because this is the root switch now, right? This is the one that is working as a root switch. So everybody needs to go in this direction. Okay, the single selected port on a switch with least path cost to the root bridge is called the root port. Root switches will never have a root port. Root switches is at the root, and therefore there is no need of a root port on this switch, right? So the cost from switch B to switch A is 4. Why? Because we are using 1 Gbps. Okay, so it's already defined that if you are using 100 Mbps, the cost is 19. If you are using 1 Gbps, the cost is 4. If you are using 10 Gbps, the cost is 2, right? So all our links are 1 Gbps links, as you can see here. Hence I have already defined the cost as 4. So for switch B to reach to the root switch, the cost is 4. Okay, hence this port is going to be your root port. Okay, similarly the cost for the switch C to travel to switch A is 4, hence this is going to be your root port. Okay, now what is the cost for switch D to travel to switch A? Now switch D has got two options. Either it can go in this direction or it can go in this direction. Now as a matter of fact, switch B also had two options, but I didn't took that example because I wanted to simplify that. Now I'm doing a little complex here. Okay, switch D can go in this direction, but the cost will then become 4 plus 4 plus 4, which is 12, which is higher than 4 and 4 here, right? So the cost from switch D to travel to A through B is 8, which is less than switch D traveling to switch E, then C, and then A, which is 12. So this becomes the root port. This becomes the root port. Similarly, this becomes the root port, and similarly it is much easier to travel on this path towards A rather than taking this one, because this is going to be 12 and this is going to be 8, similarly like what it has been for switch D. So this becomes your root port, and I already mentioned here, right? So in the next I again have to stop it here because I'm reaching my limit of recording, and in the next video we are going to see how to identify the designated port. Okay, and what is the importance of the designated port. So let me stop this and I'll see you in the next video. Thanks.